Alright guys, so today we're going to solve combustion of fuel problem having an excess air. So sa previous video natin, pinakita natin kung ano ba yung combustion at yung mga terminologies na ginagamit natin sa combustion. And then nag-solve din tayo ng problem involving complete combustion. So gumamit tayo dyan ng theoretical air, which is yung kailangan nating air in order to have a complete combustion. So on this video, we're going to solve the same problem, pero this time, we're going to use excess air para malaman natin kung paano ba ina-apply yung excess air sa mga combustion of fuel problems, no? But before that, let us try to review kung ano ba yung natutunan natin sa theoretical oxygen, theoretical air, and solve this problem. Kasi meron tayong kailangang ma-take note or matandaan dito sa particular problem na to, which will be used sa mga iba pang problem na pwede nating ma-encounter in combustion of fuels. So first, let us explain again ano ba yung theoretical oxygen. It is the amount of oxygen required for complete combustion. So, kinuha nga natin yung mga combustion reaction natin, and then makakalculate natin from there kung gaano karaming oxygen ang kailangan natin para mag-take place yung ating reaction. And then, ano ba yung theoretical air? It is the amount of air that contains the exact amount of theoretical oxygen. So, kung nakuha na natin kung gaano karaming oxygen ang kailangan natin, so we're going to calculate kung gaano karaming air ang dapat nating isupply base sa theoretical oxygen. Okay, kasi malalaman natin doon kung gaano karaming air ang equivalent ng nakuha nating theoretical oxygen. And dalawa sa kailangan nating tandaan in theoretical air is that air for combustion calculation is assumed to be composed of 21% oxygen and 79% nitrogen by volume. And in our combustion reaction, makikita natin na oxygen lang ang nagte-take place, no, sa reaction. So yung ating N2 is non-combustible or they are inert dito sa ating process. Okay, so natutunan na natin yan sa previous video. So kung hindi nyo pa siya napapanood, we advise you to watch that first bago itong video na to para mas maintindihan ninyo kung paano natin yan ginagamit. So, now we have a problem here na i-apply natin yung natutunan natin sa theoretical oxygen or theoretical air. A furnace is fired with a petroleum oil containing 80% carbon, 13% hydrogen, 3% sulfur, 1% nitrogen, and 3% oxygen. Determine the theoretical air required for the combustion of 1 kilogram of oil. So as you can see, no, dahil oil ang ating fuel, so yung mga binigay sa ating element, no, yung oxygen natin is not in O2, no, because oxygen is a diatomic element. So dapat naka-O2 siya when it is in gaseous form. But since it is part of our oil, so binigyan tayo dito ng elemental analysis in which ang ating nitrogen and oxygen are not N2 or O2, no? So, drawing muna natin yung ating diagram para mas madali natin siyang ma-visualize. So, we have our furnace here. And then, pumapasok ang ating petroleum oil. So, ano ba yung mga components ng ating oil? We have carbon, which is 80%. We have hydrogen, which is 13%. We have sulfur, which is 3%. And we have nitrogen, which is 1%. Oxygen, which is 3%. Okay, so yan yung mga component ng ating oil. And then, we need to determine the theoretical air required. So, ibig sabihin, may pumapasok na air, no? But we need to get is yung theoretical air. For the combustion of 1 kilogram of oil. So, given sa atin ang weight ng ating oil, which is 1 kilogram. So, of course, our product or our flue gas, okay, will be here. So, take note natin yung ating given. We have a basis of 1 kilogram of oil. Okay, so if we have 1 kilogram of oil, we can get kung ano yung weight ng ating mga components dito, no? So, let us say, for carbon, hydrogen, sulfur, nitrogen. So, ano yung mga weight natin dyan? Our carbon is 0.8 kilogram of carbon, 0.13 kilogram of hydrogen, 0.03 kilogram of sulfur, 0.01 kilogram of nitrogen, and 0.03 kilogram of oxygen, di ba? Now, since we'll be doing a combustion reaction dito, we will be using yung number of moles ng ating mga components, di ba? So, we need to get kung ilang kilogram moles meron tayo dito sa ating petroleum oil. Okay? Or dito sa ating fuel. But we have to take note, ano-ano ba yung mga combustible materials natin dito? So, our combustible material are carbon, hydrogen, and sulfur. So, let us see what is the number of moles of carbon. We have 0.8 kilogram of carbon. Okay, so, multiply natin or divide natin sa molecular weight ng carbon. So, our carbon is 12 kilogram of carbon per 1 kilogram mole of carbon. Okay? So, our weight of carbon will be cancelled out. So, check natin ano yung magiging sagot natin dito using our calculator. So, 0.8. Okay, 0.8 divided by 12. So, we have 0.067 kilogram mole of carbon. So, number of moles ng hydrogen. So, we have 0.13 kilogram of hydrogen. So, we have 1 kilogram of hydrogen per 1 kilogram mole of hydrogen. So, dinivide lang natin siya sa kanyang, or minultiply natin sa ating molecular weight. So, this will be cancelled out. So, may iwan sa atin is kilogram mole. So, we have 0.13 kilogram mole of hydrogen. For sulfur naman, we have 0.03 kilogram of sulfur. Multiply to, okay, sa molecular weight ng ating sulfur is 32 kilogram sulfur per 1 kilogram mole of sulfur. Okay, so our weight of sulfur unit will be cancelled out. So, ang may iwan sa atin will be kilogram mole of sulfur. So, i-check natin 0.03 divided by 32. We have 9.375 to negative 4 kilogram mole of sulfur. Okay, so meron na tayong number of moles ng ating mga combustible material. So, let us write our combustion reaction. So, lahat ng carbon natin, if we have complete combustion, will react with oxygen from the air to produce CO2. Diba? So, how much is the number of mole ng ating carbon? We have 0.067. So, 1:1 tayo. So, our O2 here will be the same, 0.067. How about for sulfur? Unahin muna natin yung sulfur dahil meron akong gustong ipakita sa ating hydrogen. No? So, our sulfur will react with oxygen to produce SO2 for complete combustion. So, our sulfur is 9.375 times 10 to the negative 4. So, 1:1. So, our oxygen will be the same. Okay? Alright. So, punta na tayo dito sa ating number of moles ng oxygen dito sa ating hydrogen. So, kung maaalala ninyo, ang ating equation or reaction for hydrogen is H2 plus 1/2 O2 producing water, di ba? But in here, our H2 is in gaseous form, di ba? Kasi naka-H2 siya. However, we have a given here of our fuel kung saan ang analysis natin is in elemental. So, we have here H. So, if you're going to write our equation, so, ito, I'm just going to write this para hindi na maging mahirap pa sa ating tandaan, ano. But I want you to use this na lang in order to calculate easily yung mga problem natin. So, we have hydrogen, okay, reacting with oxygen, producing water. Okay? So, dahil elemental tayo, no? So, balance natin yung reaction. We have H2 here. So, we have 2H and we have 1/2 O2. Okay? So, now we can use this. Itong number of moles ng hydrogen here. So, let me use that. 0.13 kilogram mole of hydrogen, and in order to get kung ilang kilogram mole ng O2, we have to calculate for that. So let's say here we said kailangan natin makuha yung O2, no, dito. I'm just going to calculate that for you. So our hydrogen is 0.13 kilogram mole of hydrogen. I'm going to multiply that dito sa ating ratio. So we have 2 kilogram mole of hydrogen and we have 1/2 kilogram mole of O2. Okay, so we have 1/2 kilogram mole of O2. Kung saan our kilogram mole of hydrogen will be cancelled out. So makukuha natin yung kilogram mole ng O2. So therefore, our O2 will be equal to 0.13 times 1/2 divided by 2 will be 1/4 of kilogram mole of O2, di ba? So that means we have to divide our 0.13 by 4. So our O2 will be equal to 0.13 divided by 4, which is equal to 0.0325 kilogram mole of O2. Okay? So, nakuha na natin yung value ng ating number of moles ng O2 dito. So, this is 0.0325 kilogram mole ng O2. Okay? So, may value na tayo ng O2. Let me erase this. Itong calculation natin dito. Since nakuha na natin yung sagot, inilagay natin dito. Medyo wala tayong space, no? So, let me just remove this. Alright, so now, tignan natin kung ilan yung ating theoretical O2. Kasi sabi natin, yung theoretical O2 natin is the amount of oxygen required for complete combustion. So, ito yung meron tayo complete combustion, di ba? So, kailangan i-add natin lahat ng ating oxygen dyan. So, oxygen required para ma-convert lahat ng carbon natin to CO2, 0.067 kilogram mole, plus amount ng O2 required to convert our sulfur to SO2, 9.375 times 10, negative 4, plus itong O2 na required para sa ating hydrogen, 0.0325. Okay, so yan ang ating theoretical O2. However, I want you to take note of this one. Meron na tayong oxygen dito sa ating fuel. Di ba? Meron na tayong oxygen dito, which is 3% ng ating fuel. So, ibig sabihin, hindi kailangan lahat ng O2 na to manggaling sa air. Kasi meron na tayong oxygen na nandito sa ating fuel mismo. So, hindi natin kailangan kunin yan sa air. So, therefore, kailangan natin subtract yan dito sa ating theoretical O2. So, ano ba tong oxygen natin coming from our fuel? So oxygen from fuel So let me write that here. So O2 from fuel is equal to, we have 0.03 kilogram of oxygen. So kulin natin ang kanyang kilogram mole. So we have oxygen here, no, but we need to get O2 kasi lahat to naka O2, no. So ano ang molecular weight ng O2? Ang oxygen is 16, but we have 2 oxygen here, so we will have 16 times 2, which is 32 kilogram of O2 per 1 kilogram mole of O2. Okay, so therefore, our O2 from the fuel is equal to, let's see from our calculator, 0.03 divided by 32 is equal to 9.375 times 10 to the negative 4 kilogram mole ang O2. Okay? So, dahil nandito na yan sa ating fuel, we have to subtract that here. So, minus 9.375 times 10 to the negative 4. Now, as you can observe, itong ating O2 from sulfur is equal ng amount dito sa O2 from nasa fuel natin. So, we can just leave this. This will be equal to 0 because 9.375 times 10 to the negative 4 minus 9.375 times 10 to the negative 4 will be 0. No? So, our theoretical O2, therefore, is equal to 0.067 plus 0.0325. So, 0.0995 kilogram mole of theoretical O2. So, ang pinahanap sa atin is yung theoretical air. Diba? So, we need to get yung value ng theoretical air. So, we have our theoretical O2, which is 0.0995 kilogram mole ng O2 times, okay, for every 21 kilogram mole ng O2 sa ating air, we have 1 kilogram mole of air. So, therefore, we can get that answer here. 0.0995 divided by 0.21 is equal to 0.4738 kilogram mole of air. So, yan ang ating answer dito sa ating question. No? This is our theoretical air for this problem. Okay, so nakita na ninyo kung paano natin ginamit yung oxygen na naandito sa ating fuel mismo to get the theoretical air. Okay, kasi kung wala tayong oxygen dito sa ating fuel mismo, so we just need to add lahat ng oxygen natin dito. Pero dahil meron tayong oxygen na naandito sa ating fuel, we need to subtract that dito sa ating mga oxygen na gagamitin. And kung ano yung lalabas dyan na theoretical O2, yan ngayon ang i-convert natin to kilogram mole ng air. So, sana naging malinaw yan, ano? Kasi makaka-encounter tayo ng ganyang mga problem. So, kailangan gamitin muna natin yung oxygen na naandito sa ating fuel mismo. Babawas natin yan sa theoretical air na isusupply natin sa furnace. Okay, so now, proceed na tayo sa pag-calculate ng percent excess air. So, sabi natin, nung nakaraang lecture natin, excess air or oxygen is the amount of air or oxygen in excess of that required for complete combustion. So, kanina napakita natin kung ano yung theoretical oxygen or theoretical air. So, yan yung required in order to produce complete combustion. Ano? But, we are supplying air in practice, no? In actual practice, we are supplying air more than the theoretical amount of air na kailangan natin. Why do we do that? Bakit tayo nagsusupply ng excess air? Bakit hindi na lang pag meron tayong furnace, na-compute na natin kung ilang oxygen ang kailangan natin, bakit hindi na lang yun ang isupply natin na air? Why are we giving excess air? Okay? So, in actual practice, sa industry, no, theoretical air is not sufficient to get complete combustion kasi marami tayong ibang mga effects or mga factors na nakaka-epekto sa ating combustion process. Two obvious phenomenon in incomplete or partial combustion is the formation of carbon monoxide and H2 sa ating flue gas or unburned combustible sa ating refuse for solid fuels. Okay, yung presence niya na magpapatunay sa atin that we are not getting complete combustion talaga. Okay, so napag-usapan na natin nakaraan kung ano yung formula for excess air, no? So let me just write it again. So sinabi nga natin before, no, yung percent excess O2 is equal sa percent excess air. So ano ba ibig sabihin ng excess O2? Ang ibig sabihin lang ng excess O2 is yung actual supplied O2 minus yung theoretical O2. Okay? So, nag-supply ka ng higit sa ating theoretical O2. So, kung gaano karami yung dinagdag mo na sobra sa ating theoretical O2, yun ang ating excess O2. So, para makuha natin yung percent excess air, ang formula natin na pinakita natin last time is excess O2 divided by theoretical O2 times 100. Diba? Since our excess O2 is equal to actual supplied O2 minus theoretical O2, so this is also equal to supplied O2 minus theoretical O2 over the theoretical O2 times 100. Diba? So, yan yung equation na dapat nating tandaan. Okay, so gamitin natin yan dito sa ating problem. So, this is the same nung sinagutan nating problem last video natin. Ano? Kaya lang, sa previous video natin, we have complete combustion. Ngayon, we have a 20% excess air. Pure carbon is burned in a furnace supplying 20% excess air. 80% of the carbon in the fuel goes to CO2 and the rest to CO. Determine the composition of the combustion gases. So, i-drawing uli natin yung ating furnace. Tapos, ang pumapasok is pure carbon. So, that means 100% carbon. So, wala tayong ibang component sa ating fuel, no? And then, may pumapasok na air. And hindi lang theoretical air ang pinapasok natin. We have now 20% excess ng ating air. So, gusto natin malaman, katulad nung hinanap natin sa previous video, yung composition ng ating flue gas. Right? So, again, we have a solid fuel here. So, my basis will be in weight. So, my basis is 100 grams of pure carbon. So, ang una kong gagawin is to get the number of moles ng carbon based dito sa ating given. So, number of moles ng carbon is equal to 100 grams of carbon. Okay, so, divide natin sa molecular weight niya. So, we have 12 grams of carbon per 1 gram mole of carbon. Okay, so, gram of carbon will be cancelled out. So, ang makukuha natin is in gram mole of carbon. So, 100 divided by 12 is equal to, siyempre, 8.33 gram mole of carbon. So, if we have complete combustion, lahat ng ating carbon will be converted to carbon dioxide. So, carbon plus O2 will produce carbon dioxide. So, alam natin kung ilan yung number of moles ng ating carbon. So, we have 8.33 gram mole ng carbon. So, 1:1 tayo, kaya ang O2 natin is 8.33 gram mole din. So, dahil pure carbon lang, yan lang ang ating reaction. So, therefore, our theoretical O2 is already this one. So, theoretical O2 is equal to 8.33 gram mole of O2. Okay, so sabi sa given natin, we have 20% excess air, no? So therefore, we also have 20% excess ng O2. So, paano yon? Paano natin ginagawa ngayon yung supplied O2? Meron tayong 8.33 gram mole ng O2 para sa ating complete combustion. Magsusupply tayo ng 20% more, di ba? 20% excess ng air. So, we will add 20% of 8.33. So, we have 0.2 of 8.33 gram mole ng O2. Okay? In many references, hindi natin sinusulat ng ganyan yan. Pina-factor out na natin yung 8.33. So, we will have 8.33 gram mole ng O2. Okay? Multiplied 2, kasi pinactor out natin yan, 1 plus 0.2. So, therefore, 8.33 gram mole ng O2 times 1.2. Okay, so pinakita ko to sa inyo kasi maraming nalilito dyan kung saan daw nanggaling yung 1.2. Kasi in many references, ito na lang bigla ang makikita ninyo, no? So, ilan yung ating supplied O2? Our supplied O2 is 8.33 times 1.2, which is equal to 10. Okay, so we have 10 gram mole of O2. Yan ang ating supplied O2. Okay, so alam na natin yung supplied O2, no? Now, let us first check ano na ba yung mga nasa flue gas natin. Sabi sa atin dito sa given, 80% ng ating carbon napunta sa CO2 or naging CO2 and the rest is CO. So that means flue gas natin, meron tayong CO2, meron tayong CO. Tapos, meron din tayong nitrogen from air. Meron din tayong O2 kasi meron tayong sinupply na excess air, di ba? So, yan yung mga component ng flue gas natin. Hindi lang natin alam kung ano yung mga values niya. So, let us see muna. Ito kasing given natin, 80% ng carbon is naging CO2. So, ano ba yung carbon natin? So, flue gas tayo, no? Flue gas. Yung carbon, 60%, tama ba? 60%, 80% of the carbon goes to CO2. So, 80% ng carbon natin is converted to CO2 and the rest, which is 20%, goes to CO, no? So, ano ba yung carbon natin? Yung carbon natin is 8.33 gram mole. So, our carbon is 8.33 gram mole. So, therefore, para makuha natin kung gaano karami yung na-convert to CO2 and CO, then, tignan natin yung chemical reaction natin, no? So, therefore, kunin natin yung actual combustion. So, sa actual combustion natin, our carbon will react to O2 to form CO2. 80% ng carbon is naging CO2, diba? So, therefore, our carbon here is 8.33 times 0.8. So, since 1:1 tayo, ano ba yung 8.33 times 0.8? 8.33 times 0.8. This is equal to 6.664. So, our O2 here is 6.664. And our CO2 is also 6.664. Dahil 1:1 tayo. Ngayon, yung ibang carbon natin, is na-convert to CO. So, carbon plus O2 becomes CO. So, to balance, we have 1/2 O2 here. So, our carbon here, 20%, 8.33 times 0.2, is converted to CO. So, 1:1 din tayo sa CO, no? So, kunin lang natin yung value niya. So, we have 8.33 times 0.2, which is equal to 1.666. So, 1.666 or 1.67 para mas madali. So, therefore, meron na tayong value ng CO2 and CO sa ating flue gas. 6.664 ang ating CO2. And our CO is 1.67 gram mole. Okay? So, kailangan nating makuha gaano karaming N2 and gaano karaming O2 yung naandito sa ating flue gas, no? So, since meron na tayong value ng supplied O2, okay? Dahil nakuha na natin yung excess na O2, so, makukuha natin yung actual air na sinupply natin, di ba? So, sulat natin itong supplied O2. Sulat ko sa baba, which is 10 gram mole. So, supplied O2 is equal to 10 gram mole ng O2. So, paano natin makukuha yung supplied air? Kukunin lang natin yung ratio ng ating oxygen sa air, di ba? So, 10 gram mole of O2 times for every 0.21 gram mole ng O2 sa ating air, we have 1 gram mole of air. Okay, so this will be cancelled out. So therefore, makukuha na natin yung supplied O2. Supplied air, I mean. So supplied air is equal to, calculate natin, 10 divided by 0.21. 47.62 gram mole ng air. Okay, so ngayon, nakuha na natin kung gaano karami sinupply natin na air. And gaano karami sinupply nating O2. So, nagsupply tayo ng 10 gram mole ng O2. Ang tanong, lahat ba yan nagamit? So, kailangan din pala nating makuha ito. Gaano karaming oxygen nagamit natin for carbon to convert it to CO, no? So, that means 8.33 times 0.2 divided by 2 para makuha natin yung value ng O2, no? So, we have 8.33 times 0.2. This is 1.67, no? 1.67. Then, ang ratio nila is 1:1/2. So, therefore, we have to divide this to 2. So, 1.67 divided by 2 is equal to 0.833. Okay? So, gaano karaming O2 yung nagamit natin dito? O2 used is equal to, i-add lang natin, 6.664. Ang calculator natin. We have here now 0.833 plus 6.664. Which is equal to 7.497. So, yan yung nagamit nating O2 para ma-convert natin yung mga carbon. Kaso, ang supply natin ng O2 is 10 gram mole. So, gaano karaming O2 yung hindi nagamit? Diba? So, meron tayong hindi nagamit na O2 eh. So, unused O2 is equal to yung supplied O2 which is 10 gram mole O2 minus yung nagamit natin na O2 which is 7.497 gram mole. So, our unused O2 is equal to 10 minus 7.497. So, 10 minus yung sagot natin kanina which is 2.5. Okay, so we have 2.5 gram mole ng O2. So, dahil unused siya, so lalabas siya sa ating furnace. So, we have 2.5 dito sa ating flue gas. Nasaan na yun? Ito, ating flue gas. We have 2.5, sorry, gawin natin siyang orange para consistent. 2.5 gram mole ng O2. Nitrogen na lang ang kulang, no? So, lahat ng nitrogen na pumasok galing sa air, okay, yun ngayon ang lalabas. So, gaano karami yung air na pumasok? So, this is the supplied air. So, supplied N2 is equal to 47.62 gram mole ng air multiplied to, so, isang gram mole ng air is 0.79 gram mole ng nitrogen, diba? So, therefore, this will be cancelled out. So, ang makukuha natin for the supplied N2 is equal to 47.62, okay, times 0.79. So, times 0.79. So, we have 37.62 gram mole ng N2. Okay, so, meron na tayo dito. 37.62 gram mole of N2. So, meron tayong amount ng lahat ng ating component dito sa flue gas. So, kailangan natin i-express that into percentage. Okay, so dahil nagkuha lang tayo dito ng basis na 100 gram ng pure carbon. So, how are we going to do that? Katulad nung ginawa natin sa previous problem natin, sa previous video, I mean. So, we need to get yung total gram mole ng ating flue gas. So, what's the total gram mole ng ating flue gas? 6.664 plus 1.67 plus 37.62 plus 2.5 is equal to 48.454 gram mole. Okay? So, kunin natin yung percentage ng bawat isang component natin, no? So, I'll write that in green para mas madali. So, unahin natin yung CO2. Gaano karaming CO2? 6.664 divided by 48.454 is equal to times 100, 13.75%. Okay, so, ang atin namang carbon monoxide, 1.67 divided by 48.454 times 100, 3.44%. And then, para naman sa N2, 37.62 divided by 48.454 times 100. We have 77.6. And then for O2, we have 2.5 divided by 48.454 times 100. We have 5.16%. Okay, so ito na yung sagot natin dito, guys. This is the composition of the combustion gases. So, I hope na intindihan niyo kung paano gamitin yung or paano tayo mag-solve kapag meron tayong mga excess air na given, ano? So, marami pa tayong sasagutang problems, guys. So, medyo magulo pa siya ngayon kasi kailangan natin talagang i-practice yung mga pagsosolve ng mga problems. So as we are solving problems, marami pa tayong mas maiintindihan tungkol sa stoichiometry of fuel combustion. So, sa next video natin, Dahil meron tayong may encounter ng mga iba't ibang klase ng fuel na gagamitin natin for combustion, kailangan makita natin kung paano mag-balance ng reactions ng mga iba't ibang fuels, no? So, we're going to do that para magkaroon lang tayo ng short review sa balancing equation para pagka meron tayong na-encounter na ganoong mga problem, mabilis natin siyang mabalance, no? Then after that, magsosolve ulit tayo ng complete combustion kung saan kukunin natin yung empirical formula ng ating fuel. Okay, so with all of that and more, I will see you in our next video.